exposure to environmental health, we really need to integrate all the data coming from all these different aspects in order to have a more wide vision of what's going on and how everything affects the health. And so we have started, as I said, this environmental health language collaborative that we call HELC. And it started really in the first attempt was in 2014, and then was not received very well from the community, and so it was put aside for a while. And then last year we decided to go back, in particularly Stephanie Holmgren, that is the one who's really pushing for this. We had a workshop, and in this workshop where some of the domain experts in the different domain came, not enough, I say. And we set some what our strategic goal and role that this initiative will have to achieve this goal. In particular, these are three main goals that we decide to, that we wanted to achieve with this initiative. And one is obviously develop a language-based solution to promote and apply harmonized language. And the role that we think this initiative should play in order to reach this goal is the create this forum to coordinate the identification of use case, because we think that starting from the use case will really help to understand which are the problem in communication are, and then prioritize activity and create this platform for collaboration in order to develop solution. The other goal that we would like to achieve is they implement the language-based solution. So apply the language standard and the best practice for accurate environmental health data. And we would like to, the role that we think HELC could have is as a community hub, where we want to identify, promote, and the adoption of a semantic approach. And we would like to offer a resource portal. And there is already, and I will show the hand, a link to this initial effort to create this resource portal, where a community could go and trying to find resources that help them to choose and see what is going on about the language solution. And the last goal is obviously advocate value of language, and so make the community of the environmental health be aware that vocabulary and cultivated vocabulary is an important part of their job. And how we are planning to do this is by exchanging information and expertise. But the other thing that I think is really important is fostering education and training, because as been said before, a lot of investigators that want to annotate their data, they are not really familiar with vocabulary terminology, in particular with ontology. And so that was exactly the first thing we tried to approach. I don't want to go through this, but in our community during this workshop, the first thing was really trying to clarify which is the difference between term list, taxonomy, taxonomy, and ontology, really taking and showing them particularly specific example. Okay, yeah. In order to do this, we have decided at this workshop that was, as I say, last year in September, that the approach we should take is really starting from use cases. And so we decide to have a unified topic that we decide to be, for the moment, the effect of 2.5 particle matters that are component of the air pollution, and which is the effect of this on asthma, exacerbation of asthma. But the use case, we are going to approach to this equal topic from 4 different perspectives. And so we have 4 groups inside the environmental community that have been working on, as I said, these different 4 use cases. One is the data discovery, and is led by Michelle English from Environmental Protection Agency. And this use case is really focused on trying to see how a minimal information templates and the use of ontology term could help to find and integrate data that are public available. The second use case that we are working on is the place-based health research. And this is the one that trying to harmonize data by understand better which is the effect of the geographic location on the environmental exposure. The third one is the data harmonization, and the other one is led by Carmen Masci from Emory University. The third one is led by Janet Stingon from Columbia University, and is the data harmonization, is trying to harmonize epidemiological data and trying to create a template-based approach to understand better and inform how the data collection should be used. And then the fourth one is about biomarkers and biological processes. And this use case is trying to, as goal to understand how the language in particular, the use of ontology can help to better understand the link between, the biomarker, the biological process and the outcome. And so today I'm really, due to the shorter time, I will just try to focus on one, and I want to show you how we are approaching and which are the issues we are coming through. So these are about geospatial data. As I said before, this was completely new to me because I never deal with the geospatial data, and I'm learning a lot, and I'm sure I'll learn much more in the future. And so these geospatial are about object, and in particular object characteristic, and an example of the object could be, in this use case in particular, the particle in the air, and an event that is exposure, and a location. So these are three main components of this geospatial data. Object and events we already discussed previously through other presentations like the ECTO presentation. So we have already, I kind of avoid to go through how we are trying to connect ontology to the exposure and exposure event. And I want to just focus on the location. So which is, how can we capture location information? And obviously, all these things is going to happen is very important, the temporal information about this. So this, I want to just go with an example. So this is how data, this comes from a paper published from one of our co-author of this presentation. And so the point is measuring the concentration of this particle in the air, in this case, in Los Angeles County. And how they do that, as you see, I think you can see this small triangle. Each triangle is the position of one instrument that is the sensor of this particle. So they are already placed this instrument all around this area that they are studying, and they are collecting information from this instrument. But what they have to do is, as you see, there are a lot of them sparse all over the LA County. And obviously, the information about the pollution is not equal if you are at a different distance from the sensor. So what they do in order to make it easier, the collection and analysis of this data, they usually trying to divide the larger region that in this case is the LA County in a smaller region that usually make advantage of geometric figure. And in particular, this case, they have divided all the area in this hexagon that have this centroid, the center of this figure where all the vertex in the hexagon, in this specific figure, are equidistant. And so they divide this area and they study, they collect the data from the sensor, and they say that all these area here is the one affected by that kind of concentration. Now, how can we trying to capture that? That is kind of very particular way of a specific way to collect data. So as I say, they are starting from LA County, and there is the Federal Information Processing System that has a specific code for each county as well as for each state. So this is an information that they take in account, not only because the code is associated with a specific, in this case, county, but because in addition to the information about the county, there are other information like population, income, neighbor, building, vegetation, all these other kind of information that are really important, and that you should kind of then collect together to have a better idea of the environmental in where you are measuring the exposure. And so this, I'm going to happen, okay, here it is. So I think we don't have, and I'm trying to rush. Because I know everybody wants to go to lunch. So the FIPS code is not present as a class in any ontology. And I think it should be as a FIPS code, general FIPS code, as to be as an identifier. And then each of these FIPS code could be an instance of that class that are related, and that's, you know, is not like this, but this is, it should be a relationship between the FIPS code and the county. And in our case, for us, for this study, is it really important to associate the county to the region, because really they have specific coordinates. So they are looking at a specific region, not really general site, but region. And so the idea was, how can we define the fact that you have a FIPS code that is about some, at the class level, about some geographic location, geographic region that has to do with the county. And we have thought, even if there is a county, list of county in gas as an instances, there is not anything that make a general, you know, definition of what could be and what the FIPS code for county is associated to, sorry. And so we are trying to propose this role, and I think that this is something that we have to discuss with the Geo, and I think Bill is here, and it could be a way to trying to make advantage of that and trying to put this information together. And the other thing that is very important for them is the fact that they divide this region, and this is not only happened to this, is how they work. So they have a larger region, and then they divide it and create this smaller region that could be, in this case, is a hexagon, could be a circular, could be a square, could be irregular polygons. So it could be anything. And they are, so these are specific geographic location that they has defined, and they define as a buffer zone. Has been a long conversation with them about what is a buffer zone. At the end, we conclude the buffer zone is really the area where they are collecting the specific data from the sensor. And there is a buffer zone in ENVO, but the buffer zone in ENVO is a site, and so it's in a material entity. In our case, we really would like to be able to link more to a geographic region that instead is a material entity, because that is the main purpose of their study. And so again, we are proposing this to be a kind of role for a geographic region that has been defined by whatever polygon they want to use in their study. And the other important part is the centroid. So the buffer zone centroid should be, that is the location of the sensor instrument. So in each buffer zone centroid is always located a sensor. And that is important because they can measure the distance from the buffer zone to all the rest of the area they are measuring. And so they have the information about the one that is more exposed respect to the one that is less exposed if the geometric region is not a regular polygon, and the centroid is not equidistant, as was in this case of the hexagonal part. The other thing is obviously there is a centroid defined in NCIT, but not any idea of ontology. And this should be a point to a geographic point location that has particular latitude and longitude measurement data. That's how we approach. I hope I can get a lot of comment on this, but just to go quickly, there are other variables that are very important for their study, and they affect the results of their study, like temperature, humidity, wind, direction, precipitation, traffic road, and temporal entity information. And they are listed, all the ontology that already covered this, so we are fine. About again, HEMVO has a road, general road entity, but if you see here, that is what they are dealing with all these different kind of road, and each of these kind of roads, so it could be a primary road, secondary road, rural road, each of these kind of road affects the ability for them to capture data, because here it is. If you are a main road, just to give you an example, these are the PM2 concentration in a traffic time, 9 a.m. respect to 2 p.m. when nobody is driving. And this is, for example, when you have an accident like wildfire at the same time and during the day. So these are all information that needs to be captured for them. And we hope that we can do it more formally using ontology relation. I'm done with my time, so I want to acknowledge all the people that has been really working on this case, in particular Stephanie Holmgren, because as I said, she is the one to promote and coordinate all these efforts. Charles Smith and Rima is the author of the paper I showed you before, Anne, that is here, and Rebecca Boyle from RTI, and Cameron Masci from Atlanta and Emory University. And the last thing before I finish is I hope a lot of you could participate to this effort, because we really need to have a different vision from different perspective. And we hope that coordinating all this will help us to come to a product that could be more generalizable. And so here are information for the website and contact information. Thank you. Chris.
Shall I come up or?
Oh, yeah, I think for the people online.
Yes, great talk. The issues you're having with gas, they are not unique to you. Everyone's having, who tries to use it, has these kind of issues. So I think, you know, this is something myself, Lynn Schrimmel, Becky Jackson, and others, and Pierre tried to address. It's a challenging problem because there's a lot of really good stuff in gas, but it's not maintained. But I think, you know, we should get together with Bill and anyone else who's interested and just have a working group and just kind of solve these issues.
Los Angeles County is not there.
Yeah.
Yeah.
I support that, and I forgot what I was going to add to that comment, but absolutely we should do that.
I think we do actually have Los Angeles County.
Oh, so I didn't find it.
Yeah, it's kind of hard to find it. It's represented as an owl individual, and so like others, for example.
Oh, we had talked about
Yeah. I saw Los Alamos and I didn't see. I looked below, but I couldn't find. But that could be my fault.
I think, yeah, we have that. We have the 3D spatial region. We have just the actual region itself on the map. We have land area and water area in Los Angeles County. But yeah, we could discuss.
Okay, perfect. That's what I would like to do. Thank you.
Hey, thanks so much.
Lunchtime.
We return at 1:30.
I'm Marcus. Nice to meet you. I really like your presentation. It's a combination of